Again, welcome to Statistics course. These lectures cover the measures of central tendency or location, which we are going to learn how to find the mean, median, and mode. So our main objective again is to determine the mean, median, and mode of a population or of a sample also. We're also going to learn how to determine the weighted mean of a data set and the mean of a frequency distribution. We're also going to describe the shape of a distribution as symmetric, uniform, skewed, and then we compare the mean and median for each distribution. Now, the skew can be skewed to left or skewed to the right, which depend on if the mean is greater than the median or the median is greater than the mean. So first, let's start with the measure of central tendency or measure of location. Here we said a value that represents a typical or a central entry of a data set is called, or we say is the measure of central tendency. So again, the measure of central tendency is a value that represents a typical or a central entry of a data set. Now, the most common measures of central tendency is the mean, median, and mode. So we start with the arithmetic mean. The definition of arithmetic mean means the sum of all values divided by the number of values we have. So suppose there are n observations in a data set, which consists of observation S1, S2 up to Sn values. Then the arithmetic mean is defined as S1 plus S2 plus Sn values divided by n. N is the number of values. So let's see example. Calculate the sample mean of the following sample data values. Here we have 4 values. So the sample mean will be 4 plus 10 plus 7 plus 15 divided by 4 because we have 4 values. So the solution here, let's assume x1 is 4, s2 is 10, s3 is 7, s4 is 15, and n is 4. So the sample mean will be the sum of all the values divided by the number of values, which is n. So we get 4 plus 10 plus 7 plus 15 divided by 4. And that will give us 36 divided by 4. And the answer will be 9. Next, we talk about deviation. So a deviation here, we say given some point A and also a data point X, then X minus 1 represent how far X deviates from A. This difference is also called a deviation. Also, what is an outline and resistant measures? An outline normally is an extreme lower or higher value comparing to majority of the values. So an outline is a data value that is extremely different from other measures in the data set. Either it will be very small or it will be very big. So a statistic measures also which are not affected by outlines are said to be resistant. This is why we have the advantage and disadvantage of mean and median. The median values normally is not affected by the outlines. So we can say it's a resistant measure. But the mean always affected by outline because when you are looking for mean, you have to add all the values and divide it by number of values. So again, it's affected. Now, next is the weighted mean. The weighted mean, let's assume there's a weighted mean of a data set with the values. The data set values are S1, S2, S3 up to Sn. Then it's given by S1 weighted is W1. So W1 times S1, same thing plus W2 times X2 plus Wn times Sn, all divided by W1 plus W2 plus Wn. So let's see an example here. Here we have a Megan. It's a freshman in a college, and she received the following grade for her first semester. Psychology 101, B, probability A, anatomy 1, C, English 101, A. Now, the grade are B, A, C, A, and each course credit hours are given. So here we are assuming a grade of A is 4 points, and also a grade of B is 3 points, and a grade of C is 2 points. Our question now is said we should calculate Megan's GPA using the grade hours as a weight. We should run it to 2 decimal places. Then B, if Megan's goal was to have a GPA of 3.4, what grade she need to make in anatomy A class to reach her goal? So first, let's solve the first question. Now, based on the question, they say we should use the credit hours as a weight. So to calculate Megan's GPA, we use the weighted mean formula with the numerical grade point values as S values, and then the credit hours as weights. Again, the question said we should use the credit hours as weights. So this means our solution will be, the first we have 3 because the grade is B. So B represent 3 times the credit hour. Same thing, the second A, and the credit hour is 4. And the third, we have C, credit hour 5, then 4 times 3. Then we are going to multiply, since the weighted will be the grade points, we have 3 plus 4 plus 5 plus 3. So we had everything. We got 47 by 15. So our solution will be 3.13. So the GP again is 3.13. But in B, we want to determine what grade Mega will get in anatomy 1 in order to get 3.4 GPA. So here we let X represent the grade in weighted mean formula. So we already know the weighted mean because it's supposed to be 3.4. So we have 3.4. We keep all the grade of the other 3 courses, except here we want to know what grade it should get for anatomy 1 in order to again get 3.4. Previously you have 3.1 when anatomy 1 at the grade is C. Let's go back very quick. Yeah, so the grade is C. C, the points is 2. So now our goal, you can see that we have X times 5. So our goal here is to find the value of X. So we are going to multiply 3 times 3 is 9, 4 times 4 is 16, X times 5 will be 5X and 12. Then we can cross multiply, we get 37 plus 5, 6 and 15. Then 15 can multiply 3.4. So we solve 3.4 times 15 equal to 37 plus 5X. And then we can solve for X. So this means we have X equal to 2.8. So approximately we can say a grade of B will be better. Since the grading scale only uses integers, Mega will have to make 3 points or a grade of B on her anatomy 1 class for a GP of 3.4. Now let's move to another concept of mean called the trim mean. So a trim mean is a modification of the arithmetic mean, which ignores an equal percentage of highest and lowest data values in calculating the mean. And we shall see example here. Now we should consider the following data taken from a poll on how many text messages a person sent in a day. So we have 16, 18, 20, up to 42. So first we find the mean of this value, which means we had all the values here and we divide by the number of values. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should add all the values. We should get 255 divided by 10. That gives us 25.5. Now, this is our regular mean value, but the question said we should find the 10% trend mean. Now, to find 10% trend mean, since we have 10 observations, removing the highest 10% and also the lowest 10% means removing only one observation from each end of the data. So remove, again, we are trimming 10%. So remove the highest 10% and the lowest 10%. So we are going to remove 16 and 42. So that is 10% of 10 is equal to 0.1. So it will be 0.1 times 10 will give me 1. So we're going to remove only 1. Now, note that the data is already sorted. That's one thing we should consider. Now, if the mean is calculated without including the values of 60 and 42, then the resultant measure is called the 10% trim mean. Again, 10% trim, the total values are 10. So which means we are going to take only 1. So we can say we remove the 1, the worst 16. First of all, the data have to be sorted, which again, in this case is already sorted, 16 and 42. Then we find the mean of the rest of the values. So we are going to add all the 8 values and divide it by 8. And that gives us 24.625. Now, if they say we should find 20% of trim mean, 20% trim mean means multiply 0.2 by 10 because the data set is 10. And that will give me 2. So that means I'll take 2 from the left side, 2 from the right side. But first, the data must be sorted. So now next, if there had been 100 data values, then the largest 10% and the smallest 10%, which is a total of 20 data values, will have been removed before the mean was calculated. So again, 10%, we have 100 data values, which means 10% will be 10. So we take 10 from left, 10 from right. So a total of 20 will be removed. Now let's consider the same data set, except that the last data value is replaced with an outline. As we said, an outline data is a data that is very large or very small comparing to the rest of the values. So here we can see a big difference, 490 comparing to 16 to 36. That's very large. So we can see the mean is 70.3. Now they say we should find the 10% trim mean. This is why the trim mean, we will say, is a resistance measure. The regular mean, the outline affected the mean. That's why we have 70.3. But to find the trim mean, we will see that the value will be way less. Now, since there are 10 observations, removing the highest 10% and the lowest 10% means we are going to remove 1 observation from each end again. So we can see that the outline is gone. And here we are going to get almost the same value we had before. But in the regular, our mean, regular mean, the 490 was so big that our mean value from the previous increased very large to 70 plus. But we can see that with the 10% trim mean, it remained the same. So the outline value in 490 doesn't affect it. This is why sometimes we use trim mean if we think there's any outline in the data to avoid it. First of all, we have to make sure the data is sorted when you are looking for a trim mean. As expected, the trim mean is not affected by the addition of the outline, but the mean increased dramatically. So the regular mean value affected by the outline. That's why the trim mean is considered to be a resistant measure. So next we move to a median. The median of a set of observation is the measure of a center that is the middle value of the data when it is arranged in ascending order. So to find the median, we always have to, first of all, sort our values in ascending order. then we take the middle value. Now, if the number of value is odd, we are going to get only one middle value. Let's say, for example, the number of values we have is 7. Then the fourth value in the middle will be the median. But if the values are 8, then we are going to take the 2 median values, and then we find the average of the 2. So let's see an example. Actually, first of all, let's go through the procedure. So as we said earlier, the first thing, we need to arrange the data in ascending order. Then we are going to determine the number of values in the data. Now we find the data value in the middle of the data set. If the number of data value is odd, then we have one median value in the middle. But if the number of values is even, then the median is the mean of the 2 middle values in the data set. So we have example here, values of 2, 3, 5, 4, 1, 7, 3, 3, 1, 2, 6. And they say we should find the median. So the first thing we need to do is sort the value or arrange it in an increasing or ascending order. So first, data must be ordered or sorted in increasing. So we have 1, 1, 2, 2, 3, 3, 3, 4, 5, 6, 7. Now let's look for the middle value. In this case, since the data set contains the odd number of values, all the values are 11, then we have only one middle value. So the middle observation in the ordered array must be the 6th observation. So the median is 3. Now let's consider the following. Here we have 10 data sets. And this will be a score calculus class, 10 values. Now they say we should find the median. Same thing we do. Let's arrange it in ascending order. Then after we arrange in ascending order, this is 10, so it's even number. So we need to take the 2 middle values. And then we find the average of the 2 middle values. So the median will be 84. Next, let's move to a mode. The mode of a data set is the most frequently occurring value. So the highest tally. So a data set is given here. They say we should find the mode of the following data. We can see that 0 will be the mode. Since the value of 0 occurs more than any other value, then the mode is 0, because 0 occurs 1, 2, 3. 1 occurs only 2, 4 occurs only once, 3 occurs 2, 9 occurs once, 8 occurs once, 10 occurs once. So the highest tally of frequency is 0. So 0 is 3 times. So the mode will be 0. Here we see, however, as noted previously, the mode does possess one very favorable property. It is the only measure of location that can be applied to nominal data, because we can see that the mode is based on counting. We count the number of the highest that have highest frequency. So therefore, for nominal measurement like color, preferences, it will be perfectly reasonable to discuss the modal color. So mean the values or the data set have to be quantitative or ratio interval. With the median is the same. Mode, it can be a nominal data set. But at the same time, it can also be a quantitative. So we may have a height of patients, and we will see which have most patients, what is their height. Height is a quantitative or numerical value. We can also use it for mode. So next we move to average, moving average. A moving average is obtained by adding the consecutive observations for a number of periods and dividing the result by the number of periods included in the average. So the best way is to use an example. Now, next section, we talk about the shape of distributions. In statistics, we have at least 3 different, or I would say roughly 4 different types of shapes. The first we're going to discuss is symmetric distribution. Symmetric distribution means at the middle of the distribution, what is on the left side is the mirror to the right side. So this means if you have a data set and it's symmetrically distributed, the mean, median, mode value are the same. So when the mean equal to the median, then the distribution set is symmetric. So here we can see the center is where we have the mean, median, mode. To the left and the right, they are the same. That's why it's called symmetric distribution. So here we say a vertical line can be drawn through a middle of a graph of a distribution, and the resulting halves are approximately mirror images. But one thing we should consider is that always a symmetric distribution, the mean is equal to the median. So if you are looking for the skewed, the answer will be 0. We will talk about this in the future lectures. Now, to find the skewness of a distribution, it will be the mean minus median divided by standard deviation. So if the mean value is equal to the median, that means the skew value will be 0. So always symmetric distribution, the skewness is 0 because the mean value is equal to the median. Now the next is the uniform distribution, which is more or less a rectangular shape. We can see it, which means everything. Actually, that's why it's called uniform distribution. All entries or classes in the distribution have equal or approximately equal frequencies. Still, the mean and median are the same. The only thing we should know is that all the observations have the same frequency or the same number of values. The next is the skewness. We can talk about skew left distribution. A skew left distribution normally is called a negative skew. And that's the diagram we have here. We can see that everything's skewed to the left. The left is very light. In this case, skewing to the left means we can see from the diagram here, the mean is different with the median and also the mode. We can also skew to the right. So here we say the tail of the graph elongate more to the left. The mean is to the left of the median. So in this case, skew to the left means the median value will be greater than the mean. So that's why the skewness of the value will be negative. That's why it's called negative skewed. When the distribution is skewed to the left, it's a negative skewed because the median value is greater than the mean. To find the skewness is mean minus median. And then we also have the positive skew. So we can see from the diagram, positive skew, the mean is greater than the median. So the mean to the right, the median to the left. So the tail of the graph elongate more to the right, the tail to the right. The mean is to the right of the median. So the mean value is greater than the median. So that will be the conclusion of these lectures. So in these lectures, our main goal was to find the concept of calculation for mean, median, mode, which is the central tendency or the measure of location. And also we discuss about different types of distribution, again, symmetric, skewed to the left, skewed to the right, and uniform distribution. Thank you.